Hey guys, so for this chapter, I'll be doing short review videos so that if you guys have any questions about the homework, I'll just go over what we went through today and what you'll need for the homework, and we'll just see how it goes for this chapter. So today, we first talked about random variables. So what are random variables? Well, random variables are usually represented by x, and these are numerical values that are associated with each outcome. Um, so for example, this might be the number rolled on a dice. For a six-sided die, our random variables are 1, 2, 3, 4, 5, and 6. Um, the 6 outcomes that are possible from a six-sided die. So random variables are typically divided into two categories: discrete random variables and continuous random variables. So you guys might remember this from our discussion about quantitative variables. Discrete random variables are finite and countable. Finite and countable random finite and countable number of outcomes. So this means that we can count these variables. On the other hand, continuous random variables are infinite, uncountable number of outcomes. So we can measure. When we talk about continuous random variables, we will be measuring them. And so the key question when distinguishing between discrete and continuous would be whether or not you're counting these objects or things, or if you're measuring these things. So here's an example. If you want to, you can pause this video and try to sort it out yourself first. I'll give you 5 seconds to pause the video if you want to. Okay, so regardless of whether or not you paused it, I'll just go ahead and sort these out. Number of students, we will count the number of students, right? We don't measure the number of students, and so this will be discrete. Heights of students, do we measure height or do we count height? We would normally measure the height, right? And so they'll be in continuous. Volume, same thing, we would measure the volume of something. Number of videos watched, these would be discrete. We will count the number of videos. Amount of money spent, do we count money or do we measure money? We would say we count money, right? And so this would be in discrete random variables. And so this is what you would do for the first part of your homework, which is to distinguish between discrete and continuous. The next thing we talked about was discrete probability distributions. So the term distributions from now on will generally mean a table or a graph of some sort. So for a discrete probability distribution, this is a table that shows each random, in this case, it'll be discrete random variables along with its probability. It has to have both the random variables and its probability, right? Let's say for this first one, let's say x is the number of heads. This is number of heads for one coin toss. Reduce that. Okay. So if I toss one coin, there's only two possible ways for it to land, right? It can either be heads or it can be tails. So the number of heads then, there's only two possible values. We can have 0 heads or we can have 1 heads. And the probability of each is 0.5. So this should be pretty intuitive. the probability of getting 0 heads is 0.5. The probability of getting 1 heads is also 0.5. So this is a vertical way to display a discrete probability distribution. Sometimes in your homework especially, they would display it in a horizontal way with the random variables on top and the probabilities on the bottom. So for example, let's say this is rolling a dice, right? I could say that there's, for a 4-sided die, there's 4 outcomes, right? I can get a 1, a 2, a 3, or a 4. And the probabilities for each is 1 over 4, right? So I'll just copy and paste this. So this is a basic discrete probability distribution. Now there are 2 rules associated with this probability distribution. In order to be legitimate, rule number 1, spend that, each probability must be between 0 and 1. So in this case, each of these numbers, 0.5 is between 0 and 1, check. 1 over 4 is between 0 and 1, check. Each probability, not each, the sum of all the probabilities must equal 1. So for every probability distribution, you have to check both of these conditions. Are all of them between 0 and 1? In this case, it is. Are all of these in between 0 and 1? It is. Let's add them all up. 0.5 plus 0.5, that equals 1. Condition 2, check. 1/4 plus 1/4 plus 1/4 plus 1/4 equals 1. Also check. So keep in mind these 2 conditions for a legitimate discrete probability distribution. So I'm just going to run through some examples and I'll tell you when to pause to figure things out if you want to. So first example, I'll just go with 0.3. Um, 0.1, 0.03, 0.4, and I want to find what goes in here, right? What goes into this blank. So we know that all of these need to add up to be 1, right? That is one of our conditions. The sum of all the probabilities must be 1. So we know that 0.3 plus 0.1 plus 0.03 plus 0.4 plus whatever this number is must be equal 1. 3 plus 0.1 plus 0.03 plus 0.4 plus, I'll call that number p, is equal to 1. And from here, we can quickly solve at 0.7, 0.8, 0.83 plus p is equal to 1. And that gives us p is equal to 0.17. So here would be 0.17. All right, so I'm going to change these numbers and I'll let you guys try it out yourselves. And delete this one. So this will be the blank this time. Change this to 0.5. All right. So you guys can pause the video for 5 seconds. Try to figure out what goes into this blank. All right, so if we add these up, that's 0.75, 0.85, 0.9. In this box, I believe should be 0.1. And we can check, we can add these all up. That's 0.2, that's 0.25, 0.5, 1. So yeah, that's basically all you need to know for this homework, and that's what we went through today. So yeah, if you have any questions after this, you can ask me in class tomorrow. And yeah, hope this was helpful.